Right, so the process is still pretty close to the same thing. You need to understand that if you have a power, you need to be aware, does that power apply to your entire base or just the one term next to it or one factor next to it? So when you're looking at a problem like this here, when we look to rationalize, we need to get this radical out of the denominator. There's no way to simplify the cube root of 6x, no perfect powers. So what we're going to do is rationalize using the same index, cube root, same base. The base is this whole value 6x. And when we build our powers to equal the index, we have 6x to the first here. Again, it's an unwritten 1. So how many more 6x's do we need to build up our powers? 2. And so what we get is 11 times the cube root. And you can either leave it as 6x quantity squared, or you can square the 6, square the x. Either one is fine. All over the 9 stays, and then the base comes out as just the 6x. Between 11, 9, 6, and x, no common factors to cancel. And so the answer would be 11 times the cube root of 36x squared, all divided by 54x. And when you enter this online, you do need to be careful with that entry. It would be 11 root 3 for the index. The whole base is 36x squared, and that's divided by. Because we have multiple factors in the denominator, you have to group those in a set of grouping symbols so that they both stay inside or stay in the denominator of that fraction. Okay? And so this would be the entry for that problem. Right, so when we look to rationalize, we need to use the same index, cube root, same base. The base here is 7x. And we need to build up our powers so that the total sum of powers is equal to the index. We have 2 to start with. How many more do we need? Just the 1. So we leave it as it is. We get 5 times the cube root of 7x all over the 3 and the 7x. The whole base comes out. Again, 5, 3, 7x, no common factors to cancel. So we're left with 5 times the cube root of 7x all over 21x. Again, make sure that this is in grouping symbols. When you enter it, it would look like the following: root 3, and then 7x, and then that's all divided by the entire quantity, 21x, and that gives you your simplified form. Okay, so we're going to rationalize with the same index, 4th root, same base, 2x. We're going to build up our power to equal the index. We need 4. We have 1. How many more do we need? Total of 3 more will get us to build that power up to the index. And so here we're left with 11 times the 4th root of 2 cubed x cubed all over our denominator is 9, and then the whole base, 2x, comes out. And so we get 11 times the 4th root of 8x cubed, all divided by 18x. Again, make sure you have your denominator grouped in a set of grouping symbols. So notice on this one, when you look to reduce your radicals first, again, pull out any perfect square factors, rewrite them as exponents using smaller bases. What you see is that no power and index can share a common factor. So 2 goes into 2 once, 2 goes into 4 twice, leaving a square root. So you can simplify this to start with, which then becomes a square root when you rationalize. Our base is 4x and 4x. When you look to simplify that, a couple things, let me go back one more step here. Okay, so when you cancel, your 2 goes into 2 once, 2 goes into this twice with that unwritten square root. So what you're now looking at is 18 over 5 times the square root of 4x. Well, can you simplify this radical even further? What is the square root of 4? 2. So that comes out as a factor of 2. So you have 5 times 2, or 10, and then it's just an x left inside. So when you rationalize, you take the same index, square root, same base x, build up your powers to equal the index. 2 is the index for square root. We have one base to start with, so we need one more. And that's going to give us our simplified form of 18 root x all over 10 times x. Again, just pull out that base from the radical. 18 and 10 do have a common factor. We can cancel. 2 goes into 10 5 times. 2 goes into 18 9. And so you wind up with 9 root x all over the denominator, since there's multiple factors, 5x. And now, if this is what you got, there's still one more thing that would need to be tested here, because we started with an even radical. Okay, just be aware of that. When you rationalize the denominators like this, you do not need to worry about absolute values. Right? So if you entered this as your solution, you're fine. But I do want you to see, like, again, when you get to the next level stuff, you might need to take this into consideration. When you look at your original number, can x be a negative? 4 times a negative all squared, so that's going to turn positive anyway, and then the 4th root of that. So you can, the x can be a negative. So when you test this by itself, is that enough to guarantee it's never a negative value? No. So technically, you would have absolute values around each of these x's in your solution. But like I said, at this stage, when you are rationalizing denominators that have variables, you don't need to worry about it. You can enter your answer just like this. Okay, and then the final example, I'm just going to kind of talk through here. When you are rationalizing, nothing simplifies. So I'm going to take my same index, 4th root, same base, 5x. Again, treat it as an entire unit. Build up my powers to equal my index. I have 3 to start with. I need one more. That gives me 9 times the 4th root of 5x all over 8 times, again, just pull out your base, 5x. And so when I simplify this, I get my answer, 9 times the 5th root of 5x all over my entire denominator together, 40x in a set of grouping symbols.